So she's trying to navigate how to.
It's only sharing the power plus, like, not that. It's only sharing this. It's not actually sharing the slideshow. And when I go into slideshow, maybe I can do it from here.
Do you have the?
Okay, so we're gonna share this.
Okay. I was gonna say if you had it in PDF, maybe that would square it away. But
It went out too much. You really need two monitors to do all this properly.
Yeah, we'll find time.
Okay, share screen. We're gonna share that version. There. We need to find all the people. Here, we got it now.
I wonder if you
Chrissy,
can.
I see it. I'm gonna
Yes.
see if I can.
I had to share it off the internet.
Okay, I'm gonna try to control host and let everybody in.
So everybody's in right now.
I'll do my best to keep up with it if you're working.
And we're gonna record this as well.
Do you wanna, should we start recording then?
Let me know when you're listening.
Looks like we got Shane O'Keefe and Patty. I should probably let Shane in.
Do we have to?
Start recording. Where's the recording?
Alright. I think so, yeah.
Record on this computer or to the cloud?
Oh, Shane will get it.
Are we ready?
Chrissy,
Yeah, I was just gonna start recording if we're ready.
go ahead.
Let's do it.
Recording in progress.
Good. Hey, good evening, everybody. Thank you for coming out on a not so lovely night.
Mic on mute.
Oh,
No, we're not muted, right?
doesn't look like it. Okay. Thanks all for coming in, and thanks for folks of us that are joining us via Zoom.
Enter Merrill. Join the meeting.
Okay, that'll be interesting. Great. So the Village Wastewater Committee was appointed by the Select Board in 2022. Its members include Larry Gubb, Sharon Crossman, Tom Metcalf, and myself, Gary Hedman. The committee would like to thank and recognize Sue West of the Wyndham Regional Commission, who has provided key support to the committee in terms of public outreach and community engagement. The Village Wastewater Project, which addresses both the North and South villages, received funding from the state of Vermont in November 2022 to determine if soil-based community wastewater systems could provide solutions to otherwise constrained or outdated septic systems. New community wastewater systems would address water quality issues as well as allow redevelopment and reuse of properties. Since that time, the committee has been meeting roughly twice a month, typically at Neighborhood Connections. Thank you to Neighborhood Connections for hosting us. It's a great asset to the community. And all are welcome to attend the scheduled meetings. The committee hosted prior public meetings in November 2022, October 2023, as well as an open house in June of this year. I'd like to also thank the Select Board and Wastewater Committee liaisons, Melissa Brown and Martha Dale, and thank Bruce, of course, and GNAT for recording and broadcasting our meeting tonight. The purpose of tonight's meeting is to present the Community Wastewater Feasibility 60% Draft Preliminary Engineering Report. That's a mouthful. Chrissy will probably refer to it as PER, which is a lot easier to say. It was submitted to the town in December of 2023. The PER represents a significant milestone in the project timeline, providing preliminary design information, alternatives evaluation, and preliminary cost estimates. The report will be presented tonight by project engineer Chrissy Haskins from the Dufresne Group, and Emily Hackett from the Vermont Department of Environmental Conservation will also be available during tonight's meeting to answer questions about the state's administration of the project and the state's involvement in the project. So I'm going to give a short bio for Chrissy and Emily, and then lay down some ground rules for the meeting. So Chrissy Haskins is a PE Vice President with Dufresne Group, based out of Manchester. She earned her master's degree in civil engineering from Norwich University in 2009 and her PE licensure in Vermont in 2011. Chrissy has been with Dufresne Group since 2007.
Join the meeting.
Currently manages their Manchester, Vermont office and has extensive experience in the evaluation, design, construction, and permitting of municipal water and sewer projects throughout Vermont. Emily Hackett is environmental engineer with the Vermont Department of Environmental Conservation. As the technical project manager for the Village American Rescue Plan, or ARPA, grants, Emily reviews engineering scopes of service, preliminary engineering reports, environmental information documents, and final design plans and specifications for projects funded by the Clean Water State Revolving Fund. So I would ask that folks, if you haven't already signed in, we've actually got dueling sign-in sheets, one by the front door and one by the door in the back of the room right now. If you could please sign in to one or other of those. The folks that are online, we will go ahead and kind of take an attendance and get you signed in as well. We're not going to have a moderator tonight. We have an agenda that was left on the seats for you, asking that questions and any discussion be held until Chrissy is done with her presentation, just to make things flow a little bit smoothly. And any questions that folks have after the meeting can also be submitted to the Village Wastewater Committee. The email address is londonderryvwc@gmail.com. And with that, thank you again for attending, and I'll turn it over to Chrissy.
Thank you, Gary. Good evening, and thank you all for coming. So as Gary noted, we're going to be discussing the 60% preliminary engineering report, or PER, and the alternatives that were considered and recommended. So I'm going to start with a quick summary of the project need. So some of the typical needs for wastewater projects. Oh, no. Hope that doesn't keep jumping forward again. Some of the typical needs for wastewater projects include health and sanitation concerns and aging infrastructure. Properly sized and functioning wastewater systems are critical to public health and environmental protection. The typical lifespan of a private septic system is 15 to 40 years, depending on soils, construction quality, and maintenance. Approximately 18% of the septic systems in the North Village and 29% in the South Village are more than 40 years old. Aging infrastructure is typical in Vermont's small villages, as is high-density development or small parcel sizes. It is more challenging to replace a septic system on a small parcel without impacting your neighbor's property, well, septic, etc. Often replacements in high-density villages are a best fit solution that do not fully meet the regulatory requirements. These are only approved by the state to maintain the existing use of the parcel, as without wastewater capacity, a home would become unlivable and a business or commercial building would become unusable. Between the two buildings, there are an estimated 24 septic systems that are within well isolation zones. 2 of these wells are permitted public water supplies. These septic systems tend to be grandfathered systems, and they are not required to improve or be moved unless an increase in use is required or requested. Another challenge that faces property owners needing to replace a septic system is the existing soils. Soils in Londonderry are generally very challenging for wastewater disposal. And they typically require a mound system or some type of innovative approach, which are costly. Proper wastewater disposal is also critical to environmental protection. Londonderry's 2 villages are located along the West River, with several parcels located within the floodway or floodplain. When flooding occurs, these septic systems are fully submerged in the floodwaters, leaching bacteria, E. coli, and other harmful contaminants into the surface waters. Some of these systems may be washed away, leaving a sewage pipe draining directly to the river. If one of these systems fails, it is possible to replace it within the floodplain, but not within the floodway. The reach of the West River through South Londonderry is considered impaired due to bacteria. The monitoring results that different organizations do throughout the summers show intermittent elevated E. coli levels based on sampling at the Route 100 bridge right here in South Londonderry. The upstream and downstream reaches of the West River are reported to be in excellent condition. So the contamination is likely to be caused by a variety of sources, including septic systems, but we cannot definitively tie it to septic systems. Wastewater capacity also has a significant impact on revitalization. Economic and community development, as well as business sustainability, tend to rely in part on available water and wastewater capacities. Due to high density development, water and wastewater capacities and opportunities are limited in the village areas for both existing and new businesses. Businesses tend to get stuck in time where they can't grow any further due to wastewater constraints. So sufficient water and wastewater capacity would allow buildings to be fully occupied, possibly with mixed-use development consisting of commercial and residential uses. Not only does this allow for revitalization of villages, but also may provide additional housing, which is a critical need in many towns, including Londonderry.
Christine, it looks like somebody's trying to possibly get in.
I think Heather's taking care of that.
It's just a delay.
So we're going to get into the alternatives. Before continuing, I do want to note that we are talking about a 60% report. So the alternatives and costs are still evolving. So you may see some, if you actually read the 60% report, from front page to back page, and I'm sure you all did, you may see that some of the alternatives or costs that we're talking about tonight are slightly different from what was in the report. And that's just based on feedback and new information that we've received since the report was submitted in December. And the alternatives and costs are going to continue to evolve as we move into the 90% report and final report and then into final design. We generally do not expect significant changes to the concepts that are being presented in the 60% and tonight. There are a couple alternatives that are still being evaluated and may have significant positive changes. And I'm going to note those as we go through the presentation. The costs presented in the 60% report and in this presentation, as well as future iterations of the report, are all preliminary and subject to change as the project develops. It's my little disclaimer. So public wastewater systems provide a reliable and low-risk wastewater disposal alternative for properties in villages, and can also greatly reduce the number of potential sources of contamination in and around villages. Options for public wastewater systems include decentralized systems, such as community systems or cluster systems, or centralized systems, such as a wastewater treatment facility. When we look at decentralized specifically, those utilize soil-based treatment methods for wastewater disposal. And the two soil-based alternatives that we've considered are subsurface trench disposal and subsurface drip disposal. So on the smaller end, is this going to jump forward again? On the smaller end of decentralized wastewater is the individual home. So this is what everybody has right now. Decentralized waste. Did we jump ahead again?
Yeah.
Just keep letting me know. Decentralized wastewater systems can also be utilized to serve a group of homes or buildings and are known as cluster or community systems. Cluster generally refers to a smaller system serving a group of buildings, and a community system refers to a larger system that's serving a group of buildings. For an individual system, the advantages include the property owner having complete control over the system, less infrastructure compared to any type of community system, and there are no costs that are borne by the town or the taxpayer. All the costs are borne by the property owner. Disadvantages are that the space required. Disadvantages are the space required on the parcel for wastewater and how that could impact the use or potential growth of the parcel. Health and/or pollution risks associated with unidentified failed systems or systems that are simply not repaired. And the property owner is solely responsible for maintenance or replacement. For a typical mound system, installation costs can range from $30,000 to $40,000 depending on site requirements. And $40,000 isn't even a cap. Depending on what is necessary, it could even go higher than that. For a community or cluster system, the advantages include lower capital and operation and maintenance costs when compared to an equivalent centralized treatment system, more space available on individual parcels for wells and buildings, improved operation and maintenance, which protects public health and the environment, and minimal property owner maintenance requirements, which are usually focused on the sewer service itself. Disadvantages are that there is a larger space required for the treatment system as compared to a individual septic system. Ongoing operation and maintenance costs for the users, so there will be annual ongoing costs to operate and maintain the system. And for those property owners who have previously paid for a septic system, the capital cost of that property owner's share of the capital cost of a community system would be a second investment for that property owner. And we're going to discuss cost of the community systems a little bit later. So centralized wastewater is typically used by larger municipalities and consists of collection system and a wastewater treatment plant. Centralized treatment plants are typically located some distance from the area that's being served and include treatment methods such as activated sludge, sequencing batch reactors, and rotating biological contactors. The advantages include greater flexibility in property use due to having the space available on individual properties without having a septic system there. And generally, these types of facilities are designed with a decent amount of excess capacity. If you're going to spend the money on constructing one of these, you're going to have some excess capacity for growth, and that allows for a lot of flexibility in terms of various property uses for the properties connected to it. Another advantage, greater environmental protection through oversight by a licensed operator and annual inspections of the system. Lower risk and cost of failure per property owner than on an individual system. So if there's a repair or replacement needed on this type of system, you're sharing that cost with everybody on the system compared to paying for it by yourself as an individual. And then again, minimal property owner maintenance requirements, which are generally the sewer service. Disadvantages are that there is extensive infrastructure required for the treatment plant, significant capital costs for the treatment plant, substantial permitting requirements, and there's regular maintenance and testing requirements, which leads to higher operation and maintenance costs when compared to decentralized alternatives. Due to the variation in type and scale of treatment for a centralized system, the cost can vary greatly, with the cost per connection of smaller systems typically being much greater than those of larger systems. Based on recent projects, the cost and scale of centralized wastewater is likely greater than what is necessary for Londonderry. And just for example, a wastewater treatment facility serving 1,500 connections has an estimated replacement cost of over $21.5 million, which equates to approximately $14,000 per connection. A smaller facility serving 140 connections with an estimated replacement cost of $12.5 million is averaging nearly $90,000 per connection. So as I noted previously, there are two alternatives for treatment in decentralized systems. Subsurface trench disposal is shown on the left as a mound system, which is the most common type of treatment or disposal system you're going to see here in Londonderry is a mound. This is also, in general, subsurface trench disposal is one of the most common methods of subsurface wastewater disposal. If we ignore the house in the background of that schematic there, a community system would look very similar to this diagram. Wastewater effluent is being pumped through pipes laid out in a grid system, 1 to 3 feet under the ground, and exits those pipes through small holes in the pipe called orifices. The wastewater effluent is treated by microbes in the soil as it infiltrates, and due to hydraulics, there's limited flexibility with the shape of these disposal fields. Subsurface drip disposal, shown on the right here, can provide more flexibility than trench disposal. Wastewater effluent is dispersed by pumping through small flexible tubing with controlled orifices that are installed 6 to 12 inches below the ground surface. These systems are increasingly popular where disposal fields are placed under recreation fields or large grassed fields, lightly wooded areas, and on sites that have sloping or irregular topography. The layout flexibility allows for installation in a variety of shapes or around fixed objects. And the subsurface drip systems require pressurized dosing and additional filtration to prevent clogging of orifices. The capital cost of these kind of systems are often comparable to or less expensive than conventional trenches. So in order to convey wastewater from individual properties to the community treatment system, collection systems need to be installed. Cluster systems, community systems, and centralized systems all require collection. In a cluster system, the collection system is usually fairly small, as the cluster system treatment site is often located close to the properties that it's serving. In community and centralized systems, the size of the collection system can vary significantly depending on the area being served. Considerations for collection include the type of collection system and the extent of the collection system. We looked at a few different options, including gravity sewer, liquid-only sewer, and low-pressure grinder sewer. So traditional gravity sewer collection involves a network of pipes and manholes to convey sanitary wastewater flow to lower elevation locations without the use of added mechanical or electrical energy. Modern gravity sewer collection utilizes PVC pipes with gasketed connections and precast concrete manholes at all junctions, changes in slope, or changes in horizontal alignment. Based on the existing topography of the two villages and where the potential disposal field sites might be, it is not possible to convey wastewater from the project areas, the collection areas, to the treatment areas entirely by gravity. The wastewater would need to be lifted using a pump station. This is not uncommon for gravity collection systems, and often they strategically locate centralized pump stations at the topographically low spot and to collect and lift wastewater over hills or to higher elevation disposal areas. Submersible pump stations are contained almost entirely below grade, with only a control panel and alarm light above grade. I will note on this little figure here, it does show a little house, a little building on top of the pump station there. That is not necessary, and many pump stations don't have that. The advantages of gravity sewer include low operation and maintenance cost when you don't have pump stations, a long lifespan of major system components, and continued operation during power outages, since traditional gravity systems do not require any power input to convey wastewater. When pump stations are required, they, per the regulations, must either have a backup power source, a generator, or emergency storage available. The disadvantages include significant disturbance during construction due to open trench excavation, which is required since pipes in a gravity system must be laid on straight vertical and horizontal alignments to avoid any issues. Areas of gravity collection system piping that see less than the normal design flow may experience solid settling and deposit buildup in the pipes, which requires cleaning. If not properly designed, constructed, or maintained, odors can occur in areas where wastewater becomes stagnant or solids are able to accumulate for extended periods of time. The pipes for this type of collection system are often 3-inch diameter pipes or smaller. And I didn't mention it, but in a gravity system, they're 6-inch or larger. Liquid-only sewers are also known as septic tank effluent pumping or STEP systems. They are well suited for areas which would require pumping of wastewater regardless of the collection method. Advantages include minimal construction disturbance, since we don't need to lay the pipes at a specific straight vertical and horizontal alignment. We can use trenchless methods, or we could use, because of the smaller diameter, we can use smaller trench installations. Septic tank effluent is low odor, and since the system is pressurized, releases of odor to the community are isolated at the intake and discharge locations only, if at all. With the use of individual pumps and pressurized sewers, a larger centralized pump station is typically not required, although it can be if there's a significant elevation increase in the system area. Most modern septic tanks can be retrofitted with an effluent pump pod to reuse the existing tank. Small pumps are used to pump filtered tank effluent and have a high reliability, low likelihood of clogging. Since the septic tank is provided at the individual property, we don't have to provide one at the treatment site, so there's less tankage there. Septic tank pump pods are operator friendly for inspection and repair. The emergency wastewater storage is provided by the individual septic tanks, and that provides limited use capacity during power outages or equipment failures. And then portable generators can be used to pump down the tanks into the collection system during any prolonged power outage. Since the collection system is pressurized, there's a lower risk of inflow and infiltration. So disposal area sizing, the treatment sizing, does not require an allowance for infiltration when we're using one of these types of systems. That allows us to use the full capacity of the treatment system for connections. And then these systems are also very easily expandable. Disadvantages are a need for a strong partnership with property owners to coordinate access and maintenance, carefully crafted and tracked maintenance plans to ensure proper pumping is provided for all septic tanks, overall higher operation and maintenance costs compared to gravity collection without pump stations, increased power usage compared to gravity due to the use of individual pumps, and there are more mechanical and electrical systems to maintain than on a gravity system. So this figure shows a comparison in profile of a liquid-only sewer called effluent sewer on the top and conventional gravity. As shown, the conventional gravity requires pipes set at specific slopes, and you can see they're all straight lines, with manholes and a pump station right there in the middle of the profile. The liquid-only or effluent sewer can be set to match the existing grade, and goes up and down with the existing grade. It does not require pump stations. An alternative to the liquid-only system that also provides the benefits of a pressurized collection system is a low-pressure grinder system. Instead of a septic tank to settle solids at the individual property, a smaller footprint grinder pump chamber is provided at each property. You can see a little image on the left corner there. The grinder pump grinds the solids into finer particles that are more easily conveyed through smaller diameter pressure sewers. As with liquid-only sewers, these systems are well suited for areas that would require pumping regardless of collection method. Advantages are very similar to that of the liquid-only sewer. And there's one additional advantage being that the pump chambers are small footprint and easily retrofitted onto small parcels. Disadvantages, again, similar to liquid-only sewer, however, there's a lot more disadvantages here. So in addition to liquid-only sewer disadvantages, grinder sewers also have, the pumps are larger than the pumps for a liquid-only sewer, and they tend to have shorter lifespans. There is a higher risk for the pipes clogging due to the solids being pumped. Limited emergency storage provided by the pump chamber, so in the event of a power outage, emergency storage or backup power is necessary. And because the solids are being pumped, we still need that tankage down at the disposal site, that septic tank down there prior to the leach field. So due to the high number of disadvantages for the grinder system, we did not evaluate that any further for the individual sites. So the North Village identified sites include the town-owned property called Custer Sharp, which is on Middletown Road, and 2 privately owned properties. The estimated capacities at each site are shown on the slide, and the potential service area is also shown in the figure here. These potential service areas are not set in stone, and they can be modified as needed depending on what might be constructed and who wants to connect. It's important to note that all 3 sites combined are undersized to serve this full area here. Because of this, cluster systems should also be considered to close the gap between the available capacity and the projected flows for the North Village. Due to high groundwater topography and floodplains, the space available for treatment on these 3 parcels is limited. Sites 1 and 3 are very limited in terms of space and capacity, and likely cannot be expanded from what we're showing here, so the 2,000 and the 3,000 gallons. Site 2 actually does have the potential for up to 8,000 gallons per day. When we consider regulatory requirements for systems over 6,500, there's a permitting cutoff at 6,500 where there's more requirements over that. So when we consider those requirements, we would have to add a second disposal field. And unfortunately, we can't fit the second disposal field on this site without pretreatment. And we are currently waiting on the mounding analysis to be completed for Site 2 to see if we can add pretreatment, to see if the soil on this site can accept more wastewater than what we've already estimated. So for right now, we're estimating the 6,490 gallons with no pretreatment. We will have the mounding analysis completed for the 90% report, and if pretreatment is possible, we will be evaluating that. If the capacity can be increased to 8,000 gallons, that would allow for additional connections. So each site was evaluated for the different treatment and collection options. The estimated construction costs are shown for the various alternatives for each site. And as you can see, the liquid-only sewer, which is this kind of, the collection is that middle section right there. So the 2 middle columns. The liquid-only sewer is lower cost than gravity sewer for all 3 sites. On sites 1 and 3, both liquid-only and gravity sewer options must be combined with pump stations due to the hydraulics between the collection area and the treatment area. But being able to use liquid-only sewer in the collection area was less costly than using gravity within the collection area for those 2 sites. Site 2 is anticipated to be solely liquid-only sewer from the collection area to the treatment site with no pump station required. For treatment options, which is over here on the right, The drip disposal had a higher cost than trench disposal for sites 1 and 3. Drip disposal does tend to be more cost effective as the treatment size increases. So we see that with site 2, we have a larger treatment capacity, and we see that the drip disposal cost has come down below the trench disposal cost. For total construction costs, we combine the lowest cost option for each site, the lowest cost of collection and treatment for each site, and we added a 35% contingency and inflation to when construction would occur. And then for the total, so that would be this middle column here, the construction cost estimate plus contingency. And then the next column over, total project cost, is the cost of the construction plus contingency plus engineering, project administration, legal costs, and easement acquisition. And to look at the affordability of each system, we calculated a cost per gallon. And so that's all the way over on the right here. And you can see site 2 is much more cost effective than 1 and 3. You can't actually see the word site 3 down there, but that bottom line is site 3. And again, as I noted before, these are 60% costs and subject to change as we move through the project development. So in the South Village, the 2 sites identified are, site 1 is the Prouty land, which is right along Route 100, kind of halfway between the 2 villages, and 1 privately owned property. The estimated capacities at each site are shown on the slide, and potential service area is also shown in the figure. Same as in the North Village, this is not set in stone. We can modify the service area as needed. And also, same as the North Village, these 2 treatment sites are undersized to serve this full area here, shown in the map. Because of this, cluster systems could also be considered in the South Village to close that gap. And again, same as the North Village, our sites, due to various constraints, are limited in terms of space and capacity. Site 2 is unlikely to be expanded beyond what we're showing here, the 3,000. Site 1, the Prouty land, does have the potential for up to 12,000 gallons per day. And again, we're waiting on the mounding analysis to come back for that to see if we can actually put that much wastewater into the ground there. It would require pre-treatment, same as the discussion we just had about the one in the North Village. If we can use pre-treatment to increase this capacity, and here we do have the space to add the second field without reducing the size of the fields, we can add the second field and double this amount. So if we can add pre-treatment to increase the capacity and the soil can actually accept that, we would double the size of that system and allow for several more connections. So again, we evaluated each site for different treatment and collection alternatives. Estimated construction costs are shown for the various alternatives. And in this case, liquid-only sewer is lower than gravity on both sites, and in both cases anticipated to be solely liquid-only sewer, no pump stations. For treatment options, drip disposal had a higher cost than trench for site 2. Again, that's a smaller capacity site. And on site 1, the drip disposal was the lower cost option. Total construction cost was calculated again, the same as the North Village, 35% contingency, inflation to when construction would occur, and total construction cost was calculated that way. Total project cost adds in the engineering, the project administration, legal, and easement acquisition. And again, you can see that the larger site is more cost effective than the smaller capacity site. So based on these evaluations, We are recommending one site for each village. So this would include site 2 in the North Village, which is that's the larger private site, and site 1, the Prouty land in the South Village. These were the two options that were identified as being significantly more cost effective. These two sites would not provide capacity for the entire potential service area in either village. However, they would make a positive impact on priority parcels in both villages. In the North villages, most of the parcels are considered priority, but not all would be able to connect if we were at a 6,200 gallon a day, 6,490 gallon a day system. And again, we're recommending the town look at cluster systems to fill the gap there to better serve the North Village. In the South Village, once the priority parcels are considered, there is additional capacity to potentially serve several homes on top of the priority parcels. And when I say priority parcel, what I mean is that those parcels are in the floodplain, the floodway, they have restrictions for septic replacement, and or they provide critical services to the town. With the limitations, these parcels would be given priority for connection before moving on to other parcels in the area. And as a reminder, both of the recommended sites to move forward with have the potential for higher capacity, and we'll be confirming that prior to the 90% report. So you'll see here on the North Village, we say that it serves 23 residential units, or a combination of residential and commercial, and the South Village 22. So obviously in both cases, we're not serving solely residential units. A single family home or an apartment on a system like this would have the same design flow regardless of bedrooms. A commercial property can have varying flows depending on what the use of that property is. The numbers here represent how many single family homes or apartments could connect without any commercial uses connecting. And it's solely for the purpose of developing an estimated residential user cost. The actual number of connections for both villages would be different than shown here when commercial uses are considered. And I also wanted to point out, under the funding, the North and South villages are two completely separate projects. So each village has been awarded ARPA grant funding, and this funding is specific to those villages, to each of those villages. The funding for the North Village cannot be used in the South Village, and vice versa. So these projects can move forward separately. The town may choose to move forward with one without the other. And the town is currently in discussions with the state to determine the feasibility of moving both projects forward. So what does the service look like for each system for each of these systems? So I've given you the numbers 6,490 gallons and 6,200 gallons, but what does that actually mean? Who's actually going to connect under those volumes? So in the North Village, 6,490 gallons per day can serve all the properties on the south side of North Main Street based on the current use as of December of 2023. We would have approximately 1,000 gallons remaining to address vacant or underutilized buildings or a couple connections on the north side of North Main Street. If we can increase the capacity there to 8,000 gallons, the entire, all of North Main Street, both south side and north side, would be able to connect based on the current uses of each property. So properties that are currently vacant would have they would have 0 gallons per day for connection. But any existing uses would be covered under that 8,000 along North Main Street in that area that we showed. In the South Village, 6,200 gallons per day can serve the town hall, church, corner market, fire department, post office, library, town office, and town garage, all based on the current uses as of December, plus approximately 11 residential units. If we could increase the capacity to 12,000 gallons, if we can double that capacity with the pretreatment, that would allow for potentially another 20 residential units in the South Village. So in order to estimate user costs, the annual expenses of the system are calculated. The ARPA grant that the town has received for each village covers 100% of the design, administrative, and easement acquisition costs and 90% of the construction costs. So based on the total project cost estimates, the ARPA grants would cover approximately $2.63 million in the North Village and $3.96 million in the South Village. The remaining local share would be covered by a loan. And in this scenario, we are anticipating a loan from the Clean Water State Revolving Fund at 0% interest for 30 years. In addition to the local share, the annual capital payment there, we would have annual operation and maintenance costs. And so combining the annual capital payment and the annual O&M costs, we come up with total annual expenses of $17,500 for the North Village and $22,200 for the South Village. So this is the cost that needs to be paid for each system each year. This can be paid using various fee structures. We are presenting two options here. The first option is that the users for the system pay for the entire system cost. So if you're connected to the system, you pay for it. If you're not connected to the system, you don't pay for it. For a residential unit, so the single family home or apartment, the estimated annual user fee under this scenario would be approximately $760 if only the North Village was constructed, or $1,010 if only the South Village was constructed. So the North Village column and the South Village column are based on only one system being constructed. If both systems were constructed, they would be operated under a single wastewater utility, and all of those costs would become combined. And so the annual residential user fee would be estimated at $880. So the second fee structure that we evaluated includes spreading the one-time capital cost of the system, so that local share cost, or the annual capital payment, which is just the local share divided by 30 years. Spreading that cost over the entire grand list of the town. So the users would still be solely responsible for operation and maintenance of the system. And the annual, so that one-time capital cost spread over 30 years. Using the town's current grand list value, a property valued at $200,000 would pay approximately $4 per year for 30 years for the North system, and $6 per year for 30 years for the South system. The users of the system would pay those same amounts, those $4 and $6, plus the annual operation and maintenance costs. And so the bottom row of the table here shows the impact to the user rate if that one-time capital cost is spread across the grand list. The North Village residential user fee drops to approximately $420, and the South Village to $460. And again, those are only if one system is constructed. So if both systems are constructed, that $200,000 valued property would be $10 a year across the grand list, across everybody in town, and the users would be paying for approximately $445 a year. Let's see here. And again, I've said it a lot of times, these are preliminary costs and subject to change. The select board will ultimately make the decision on how user fees are structured, and this will depend on what ends up being constructed and what the final costs end up being. The local share will need to be covered by other grant funding or a bond vote. And at this point, the town is planning on a bond vote, which could then be reduced in the future by any other grant funding that becomes available. And the voters of the town will vote on the bond. The select board will also either become the sewer commissioners or appoint a separate board of sewer commissioners. And the sewer commissioners will have final decision on who connects, development of ordinances, and general administration of the system. So moving forward, the project's going to be progressing more quickly. Priority list application will be submitted next week to keep the town eligible for the ARPA funding. So the funding you already have, we do have to submit an application every year to remain eligible for it. Following this meeting, the select board will decide on how to proceed at their next meeting on January 22nd by approving a bond vote warning. There is some concern from the state that a single town, in any town, not Londonderry specifically, but any single town cannot move 2 projects forward in the allowable time frame. The state is encouraging any town that has 2 projects to select the one that is most feasible to proceed to construction. So the town is currently in discussions with the state to determine how to move forward with one or both projects. All ARPA funding must be fully expended by the state by December 31st of 2026. This is a requirement of the federal government. If the state does not fully expend the money by that date, they have to give it back to the federal government and the state loses it. So that means all the towns in Vermont lose it. So this means all work must be completed and reimbursements issued to towns by that date. In order to meet this schedule, the state has set some deadlines for various tasks throughout the project. The final report must be submitted along with our environmental review by April 15th, 2024. Final design, all permitting, and all easement acquisition must be completed by September 30th of 2024. And construction closeout must be completed by August 31st of 2026. Failure of any ARPA grant recipient to meet any of these deadlines will result in a loss of funding. So before we move to questions and comments, of course it lost that. I'll just do this. Please note, if your property was not included in any of these figures on here in the shaded areas, that does not necessarily mean you can't connect. If you are interested in connecting and you're in close proximity to the potential service areas, please contact the committee so we can provide you with a preliminary determination on potential connection. Gary noted the email address to begin with, but it's up here also, and I think it's probably on that paper as well. So londonderryvwc@gmail.com. Please send an email if you're interested in connecting or if you have any comments or questions about the 60% report or the project in general. We are happy to answer those and we'll be responding to any emails that come in. And that's all I have, so thank you. Questions?
Do you want to go back? Yeah.
Move it out here, you mean?
Yeah.
Go for it.
You've mentioned pre-treatment, and so is that something that needs more infrastructure too, or what is that?
That's a good question. So pre-treatment is, it would be located at the disposal site. And what it would be is some underground tanks so one of the options we're looking at, they're all proprietary types of things. They are basically like filters, so they're underground tanks, and the wastewater can filter through them, and it cleans the wastewater more before it gets to the disposal site to the actual soil treatment, so that the hope is that we can put more of that into the soil at one time. So we're pre-cleaning it basically, but it's all underground at the site. The only thing that might be above ground at the site is a control panel for it.
Chrissy, is that like a filtration system to take out more particulate in order to make sure that mostly only water goes to the disposal field?
Correct. Yeah.
And you don't have to like clean the filters or?
There is maintenance associated with them. It's not a huge additional cost, and if that is something that we find we can do, we'll adjust the operation and maintenance costs that we have in here to account for that.
If, if the residential connections are voluntary, what happens to the cost scenario if a lot of people elect not to connect?
So the costs that I showed here and that residential cost, that per residential user cost that I was showing, that does assume that the full capacity of the system is being used. So if we're only going to use half the capacity of the system still needs to be paid for. And so that would increase that user cost. So we do want to get as many people connecting as possible.
But I mean, if there is a undersubscription to the cost, just like you showed in the separation of the capital versus the operating costs, those operating costs being pushed in effectively into the capital cost because you have to share it among other people or have to figure out some other way of paying it back. It would increase, let's say if we did both projects, right, from $10, if only 50% subscription would increase that to $15. Is that like, if we assume that we've got, you know, a split of 50-50 on operating costs and maintenance costs and the capital costs, which is at about what I think you showed. So does that make a sense to what that increase in cost would be if it's not fully subscribed? That's one option for the select board to consider, correct?
Yes, so I think what Tom's saying is that if necessary, in order to maintain those lower user costs, to make it affordable for users, the town could choose to kind of subsidize some of the operation and maintenance costs of the system across the grand list. That's something that would be up to the select board to decide.
Not desirable, but you know, that might be a condition.
We have a question here in the back.
All right, so what happens to some of the marginal systems right now that are probably on the cusp of failing or have failed and stuff? And it's like, if it happens within the next 12 months or something on it. The reason I'm asking, it's like I've got a marginal system right now, did repair, it's okay right now. I'm a real estate broker in this area. The last 2 transactions I've done in here, in this area, had 2 failed septic systems. And I can't even imagine asking somebody to shell out $40,000, $50,000 to do a septic right now when this is coming, but not fast enough. So in the interim, when something like that happens, what do you do?
I think I probably need to get back to you on that because it's actually not. I would have to talk with some of the regional engineers about how they would handle that. They might be able to somehow get the system by until this can be constructed. You know, that would certainly be up to the regional engineers. But I would imagine they'd be reasonable in trying to come up with some sort of interim solution. But I can't promise that.
Yeah, I mean, it's like you've talked about it before and in the village and stuff like that. It's like there's nowhere to put any other systems. I mean, I know where my system is. The well is like 20 feet away for the neighbors.
Oh, yeah.
And I've done inspections all along this river and had the inspector say, you see the camera? That you're looking at the bank of the river on the other side of the river. And it's like, it happens over and over again. It's like I just, you know, this has got to happen, I think. Thanks.
Do we have any questions on?
I don't see any.
If anybody on Zoom has any questions, feel free to raise your hand unmute.
Chrissy, I've got another question just for the edification for the people here and on the web. The costs you presented for the various systems, they're not just raw costs, they include an escalation factor or a contingency factor. What percentage of the basic cost for construction was included in your contingency factor?
35%.
35%.
Plus 2 years of inflation after that. And that's normally our contingency. A few years ago, our contingencies would have been at this stage of the project, maybe 25%, but there's a lot of volatility in pricing right now, so we've upped the contingency. Yes.
So, once the system is built, how is that affected by flooding in Londonderry, in South Londonderry? Does the flooding in the village affect the system?
So the flooding in the village would not affect the system. The treatment site itself would be outside of any floodplain. Actually, under the funding, we're not allowed to put treatment systems in the floodplain at all. And in, I think in all of these cases, we're looking at the liquid-only sewer for collection. So there are no manholes where water can get into the manhole and overwhelm the system. So this would be, we would have septic tanks, and there's things we can do to raise those, access points up if we need to. So we would be protecting the system against the flooding. In consideration of where to put the pipes, we're looking at putting them not on the river side of the road, on the other side of the road to better protect them. Martha.
Chrissy, when you gave the presentation to the select board the other night, it was really helpful when you explained that the maps that you had and the color blocked out were merely the residential areas that could be using the systems. It wasn't identifying where the site was, like site 1 or site 2 for
Correct.
the field itself. Is that right?
That is correct. So those maps with the blue and the red and the green areas on them, those would be the collection areas. And again, those aren't set in stone. If only one site is constructed and there's 3 collection areas, then we might be able to pull people out of other collection areas and connect them to that one site. But the disposal areas, we haven't shown them on any of the maps yet. I think most people probably know where the Prouty land is. And we'd be looking at kind of the northwest corner of the Prouty land. The other site, the site for the North Village, is privately owned, and I haven't confirmed with the property owner yet if he wants that public right now. It will be public. Obviously, we do need to provide some maps and drawings for the final report, so it will be public. I just want to confirm it first before we put it out there.
So I was gonna ask if the property owners have already agreed to.
Yes, so the property owner, we haven't entered into any actual easement paperwork yet, but the one private property owner is very interested.
Can you speak to what the annual O&M costs cover and how that, I guess, adds to the life of the system as we're moving away from private septic systems? Now we're talking about a community system, and what the lifetime of that system would be expected to be, and why that's different from a private system.
Sure. So in terms of operation and maintenance, with liquid-only sewer, the tank that would be located at each individual property, it has a pump pod in it, and that has a filter in it, so that filter would be changed regularly, whatever the manufacturer's recommendation is. So that would be part of O&M. Electrical costs to run the pumps is part of operation and maintenance. Any pre-treatment at the system would be included in that. So electricity for pre-treatment, any sort of maintenance that's needed to change filters or change media would all be included. For drip dispersal systems, again, that does require electricity. Drip dispersal systems actually flush themselves out. So your conventional leach field or mound system doesn't flush itself out. Drip dispersal systems do flush themselves out. So that extends the lifespan of them as well. And then any sort of distribution system maintenance, if there's any flushing needed, there would be clean outs in the system. So if any pipe flushing is needed, that would be all included in the operation and maintenance costs. And I think at the beginning I said individual septic system is a lifespan of somewhere between 15 and 40 years. These systems are expected to extend beyond 40 years. It's hard to throw out an exact number, but we could be looking somewhere between 40 and 80 years. So just because of the regular maintenance that's happening on these types of systems, and especially if we go up into the 8,000 and 12,000 range, the permitting requirements actually require more operation and maintenance, or more maintenance, I should say. And so that's going to extend the lifespan of the system. Whereas at your house, you're probably not doing a whole lot of maintenance on your system.
You said that there are electric pumps at each of the tanks on the individual properties.
Yes.
Those are waterproof?
Yes. Yeah, so they're, the pumps are actually down in the tank. And then the electrical controls for them are, anything that's in the tank is, I forget what the rating is for them, but they're rated to be submerged. Anything electrical that is in the tank is rated to be submerged. And then there is usually a small control panel that would be mounted on the side of a house. That is all, again, weatherproof.
Okay, will that control panel that's on the side of the house or with a commercial building, will that be above what's expected to be flood stage?
Yes, that would, yeah, we would need to be placing everything above flood elevations. Yes?
On your estimated user costs, I got confused because it said on the top part of it, the annual operation and maintenance costs are like $9,500 and $10,000. But when you get down to the annual residential user fees, it's only $742 and $1,009. It was slide 19.
So the O&M, the 9,500 and 10,000 for each village, that is split across, so we've split that across the users. So the 22 and 23 residential users that we calculated for these systems. So that's those costs divided by.
Okay, it's total cost versus
Yes.
individual.
Yeah. Yeah, so these costs, the ones that were in red on that slide, are what a single residential user would pay for the year.
Thanks.
Yes.
You mentioned that both villages would benefit from a pre-treatment and larger drip dispersal fields. Do you know what those costs will be? Because I imagine if they're allowed, they're going to be what is pushed through.
So if we can do the larger capacities using pre-treatment and larger fields, we will be updating our costs for that. The costs obviously will go up, so that total number will go up, but we're also going to have more users. So we've just done some rough numbers already, and it looks like the user costs would be similar to what they are now.
I was just looking at what the bond vote would be versus what it looks like now.
I can't tell you that right now, but I will have to tell the town by January 22nd. Yes.
So, looking at the math a little bit differently, if you're an individual homeowner facing replacement costs of your septic field every 20 years and you're going to spend $40,000, that would be an amortizing cost of $2,000 a year. So this system actually is pretty economic in the long run for residential folks.
Correct. And you have no more maintenance to deal with.
I would say that number's a lot higher, having just.
Oh, dear.
I would say double it.
That, I will say that range that we gave for the mound system, that's for construction of a mound system. That doesn't include any engineering for it or permitting fees. That's just construction.
$4,000 a year.
Yes.
So it's just a question about the existing tanks that are at each house and stuff would be utilized and have a filter on it going out to your lines?
Yeah, so the existing tanks, if they're in good condition, we would reuse them, and if not, we would replace them.
But that would be extra cost, probably.
We've actually factored that in. So these costs actually, the costs I had today included replacing everybody's tank. I'm just assuming worst case scenario.
Would the cost go down if you don't have to replace the tank?
Yes.
That's like $5,000.
So, yes, yeah. Yeah, we haven't actually evaluated anybody's tanks, so I just assumed that they all had to be replaced.
Chrissy, can you tell us what would be required of the system components if you were to reuse an existing septic tank? Would it have to be somehow pressure tested or leak tested to make sure we didn't have an inflow or infiltration problem with this existing tank? Or you don't know that?
I'm not sure about that. I don't know what kind of testing we would need to do on it, if any.
Certainly a visual inspection. If nothing.
Yes, we would do a visual inspection of it. If there was any signs of deterioration, we would just replace. And then if we could reuse it, we can just retrofit it with a pump pod.
Chris, would there be, I guess, rules/regulations for users if they were to hook into the system, like garbage disposals, different waste loads? Can you speak to some of those, I guess, requirements that would basically prolong the life of the system?
Sure. So the town, if a wastewater system is constructed, the town will need to create a sewer ordinance. And that ordinance will have restrictions on what you can put down the drain. So you can't put hazardous materials down the drain. You shouldn't be putting a lot of fats, oils, and greases down the drain. Nothing with high. I'm going to get into technical terms here. High BOD. So if you're brewing beer, don't dump that down the drain. Don't empty your entire wine rack down the drain all at one time. Things like that. High sediment loads, unusual pHs, anything like that could not go down the drain.
Chemicals, including chemicals like cleaning products?
It depends. I mean, it depends on what the product is and what the volume is. We're looking at like unusual things. Like normal cleaners that you're using in your house are not typically an issue. There would also be, generally we don't want garbage disposals. We don't want you connecting your sump pump in your basement to your sewer line. We don't want you connecting a roof drain to your sewer line. Things like that. So that there would be an ordinance that spells out things that are prohibited to be sent down the sewer, and rules about the use of the sewer.
I don't know whether there's any online.
Don't see any hands up.
Why don't we make it ask and see if anybody there wants to speak? And are those in the sidebar, are those comments or questions that?
No, that's just,
Something else?
that was just, we're gonna be getting started at 6 o'clock, and here's the email address. Yeah, so if anybody on Zoom, again, if you have any questions, feel free to raise your hand. Doesn't look like it.
Should we just throw out, like, what if everybody here and all of their friends decided this was a great idea? How would it get started and how long would it take and things like that? Is there just like a scenario you could paint for people?
Well, basically, we're gonna get the final report done, and we're gonna jump right into final design. I will note, the final design is free. It doesn't cost the town any money. And ultimately, it is up to the select board. But you can just continue to move forward with final design, even before the bond vote. That is something that the town does not have to pay back. So if your bond vote fails, or even if it passes and the town decides not to move forward with construction, you don't pay back the design costs at all. That is 100% grant from the state. Even if the town goes and acquires that one easement from the property owner, that is 100% grant from the state. So these are things that we likely would, with the select board's approval, move forward with, just to keep things moving along. Because in order to meet that schedule that I had there, we have to keep moving forward. If you recall, the final design has to be done by September 30th, and that includes all permits in hand. So we have to apply for permits this summer. So time is very tight. From there, we would go into bidding. Construction bidding would be, it has to be done by August of 2025, but it would probably happen over the winter of 24-25. And then into construction in 25. Basically moving along as quick as possible to make sure all the deadlines are being met. So that's kind of what the schedule would look like. We really have to follow the state's schedule on this. Like I said, if any ARPA recipient in the entire state, anybody in the state who's receiving ARPA money for village wastewater, if they don't meet any one of these deadlines, you lose your funding. And if you lose your funding, all the design and any land acquisition and all that is still covered, but you lose all your funding for moving forward.
Thank you.
For moving forward, what happens if you don't meet the project closeout date that you showed on there, I think August 2026? You've done all your construction, presumably you've gotten refunded through the state on each payment request as the system's getting constructed, but you missed that final deadline. Is there a penalty for that? Do they claw back everything?
That would be a good question for Emily, if she's still on. Yep, she is.
Yeah, sorry, I put popcorn in my mouth. Sorry. Can you say the question one more time, because it's hard to hear some of the questions in the audience, so can you say it one more time?
The question is if, so if we've gone through construction and we've been reimbursed all through construction, but we missed the closeout date of August 31st, 2026, what happens then?
Well, you know, given the cost of the projects, right, and you guys are gonna have your own additional funding, you would want to spend every single grant dollar first. And then once that money is spent, right? So at that point, you're probably more likely going to be into the funding that the town has to secure through borrowing. And so it may not be an issue, but literally you're going to spend all your grant dollars first and then spend the money that you're borrowing. I hope that answers your question. It shouldn't be an issue because of that.
Thanks, Emily.
I just had another question.
Go for it.
So you talked about maybe needing, I forget, the cluster system as well as this, what we're talking about?
Yeah, so we'll have a better idea once we get the bounding analysis back. But in the North Village in particular, one of the things that we've been talking with the state about is adding some extra cost into the funding application for designing, for looking at and designing some cluster systems to complement a community system if something is moving forward in the North Village. And again, that design would be 100% grant. At this point, I don't know if we would have the construction funding for it, but we could at least design some of them with grant money.
So you just kind of fold it into these projects?
seeing a lot more faces on the screen now.
Oh, I changed it to,
I'm just looking.
yeah.
Some of those people.
So any other questions?
I don't have a question, I have a recommendation that based on this meeting, if people in the audience, or people in the Zoom meeting have interest in this project, see themselves as being, wanting to be participant or a connector, that they please advise the, you know, the committee and to let us know that we're going in the right direction, you know, and that this is something that's got some momentum, at least for, at least the critical people, or the critical areas.
So it sounds like even if you don't have a question about the project or interest in connecting, maybe even reach out with an email to the committee to
Sure.
show support.
It's sort of one of those things, like, you might not need it now, but sometime you will. And you'll be glad you did.
Okay.
I can make this, this is a comment from another engineer like yourself. He's from New Hampshire. And it's probably 10 years ago, he told me that septic systems are designed to fail. They do not last forever. They will fail at some point. And it's just, you know, you don't want the jackpot because I've seen that and it's expensive.
That is true. They do not last forever. They might last longer than they're expected to, but they don't last forever.
Thank you.
Thank you. I was just gonna ask you if you have any idea when the 90% presentation might happen.
90% presentation, no, I don't. The 90% report will be submitted by February 1st. The state will have to review it, and the final presentation will be after that.
Okay.